Today's video is going to discuss Chapter 2.7, Translations and Reflections. So we're going to start with the idea of a translation, which is essentially moving an object on a coordinate plane. So if you think about JKLM as a rectangle, it's being translated or moved 6 units to the right and 4 units down. And we want to find the new coordinates. So if you think about when you move something left or right, this is going to be your x-axis. So I'm going 6 to the right, moving this direction along a number line would be positive. So I'm going to go positive 6. So I need to add 6 to my x-coordinate. And then y, up would be positive and down would be negative. And I want to go 4 units down. So I'm going to take my y-coordinate and I'm going to go minus 4. So if you think about these as the coordinates of this rectangle, I want to go 6 to the right and 4 down. So my new j, which I'm going to call j prime, and I show that with j and apostrophe, is I'm going to take 6, I'm going to add 6 to my x value. Remember, this is x and this is y. So I'm going to add 6 to x. Negative 2 plus 6, this is going to be positive 4. And then my y value is going to be this 5 minus 4. 5 minus 4 is 1. So j prime is now at 4, 1. K prime, I'm going to do the same thing. I'm going to take negative 2. I'm going to add 6. Negative 2 plus 6 is positive 4. I'm going to take 1. I'm going down 4, so I'm now going 1 minus 4. 1 minus 4 is negative 3. L prime, some of you may want to think about working ahead of me now, if you feel like you got a hang of it. I'm going to take 6 and I'm going to add it to the negative 8. Negative 8 plus 6 is negative 2. And then 1 minus 4 is negative 3. And then finally, M prime, negative 8 plus 6, this is negative 2. And 5 minus 4 is 1. So what you should notice is as I move this rectangle, these two shared an x, and these two shared an x in the original shape. And in the new shape, once I've moved it, these two still share an x, and these two still share an x. And if you look at these two shared a y in the original, they still share a y. These two shared a y, and now they still do. So it hasn't necessarily changed the shape. And if you were to put these on a graph, in your textbook you'll see what the graph of this shape and this shape looks like. You'll see it's an identical rectangle. It has just moved 6 to the right and 4 down. Right? So you just basically took a rectangle, if you can think of it, and just moved it 6 and 4, and then that same exact rectangle would be over there. All right, I want to talk next about reflection. So the idea is reflection can be thought of as a flip. So if you think of A, B, C, D as my original shape, if I were to reflect this or flip this over the y-axis, which is here, I'm going to take this shape and I'm going to move it this way. So this will be A, and this will be D, right? So I guess call it A prime and D prime. And then as I flip this, this would be my B, and this would be my C. So a lot of times people feel like you just slid it over. That's something different, right? That's what we just did. Was a translation. A reflection means I take this and I almost, as if we're on a hinge, and I flip it over. So this is my mirror. If I want to flip it over the x-axis, which would be here, I'm going to take this A, this would become my A, this is the D, this is C, and this is B. Right? So it kind of came over and flipped to here. Now, a couple things to keep in mind. As I flip it over the y-axis, I want you to notice that the y coordinates would not change. So for example, if, let's just pretend this were 3, if this were at, I don't know, let's call it 1, 3, if A were at 1, 3, so 1 and then 1, 2, 3, then A prime would be at negative 1, 3. So I want you to notice is that when I flip over the y-axis, the y stays the same, and the x becomes the opposite. So it was a positive 1, now it's a negative 1. Let's say this was 1, 2, 3, 4, 5, 6. So this would be 6, comma 3. Over here would be 1, 2, 3, 4, 5, 6. This would be negative 6, comma 3. Same thing, right? The y stayed the same. The x's are opposite. Now if you were to go onto over here, let's say d was at 1, 1. This d prime is going to be at 1, comma, negative 1. So the difference here is I flipped it over the x-axis, which is why the x's remain the same, and the y's are the opposite. Same thing over here. This would be at 6, comma, 1. This point here would be at 6, comma, negative 1. So as I flip over the x-axis, you notice the 6's remain the same, the y's became the opposite. So that's the confusing part. A lot of times when people reflect it over an axis, they want to make that the value that flips. In reality, when you flip over the y-axis, y's will remain the same. X's become opposite. When you flip over the x-axis, x's will remain the same. Y's will become opposite. So we're going to try this without looking necessarily at the shape, and then I have one for you to practice. This is a rectangle. So we're going to take D, E, F, G, and we're going to reflect it over the y-axis, which means, remember now, the y's will remain the same. The x's are going to become opposite. So D prime is going to happen at the opposite of the original x, which is negative 4, and the y will remain the same. E prime will happen as I'm coming over the y-axis, the opposite of x, so the opposite of 5, and then the y remains the same. So these y's are going to stay the same throughout. F prime is going to happen, the x has got to go opposite, so it's going to be negative 2, and then the y stays the same. And then G prime, the opposite of x, and then the y remains the same. Now keep in mind, had one of these numbers been negative, then these would have become positive. So these 4 numbers are now negative because these 4 numbers were positive. Right? If I were to reflect it back over the y-axis, then this would become a 4, 5, 2, 1. All right, I'm going to have you practice. Here's a triangle for you. The triangle ABC is at 4, comma, negative 2. B is at 0, 2. C is at 5, 2. I want you to reflect this triangle over the x-axis. You can pause the video at this time to practice this problem. All right, since it's being reflected over the x-axis, A prime x is going to remain the same. So my 4 will remain intact. I'm going to take the opposite of the y. The y here is negative 2. The opposite of that is 2. B prime. 0 stays. Take the opposite of 2. That is negative 2. And then C prime, the x remains, so that's the 5. And then the opposite of 2 is negative 2. So that would be my new triangle. Thank you very much for watching the video. I'll see you in class.